Hi everyone, myself Yalini, Assistant Professor from the Department of Computer Science Business Systems. Today we are going to discuss about a topic of algorithmic problem solving steps under the topic of computational thinking and problem solving in Python programming. Okay. First, algorithmic problem solving steps. Okay. Before getting to the problem, we all have to know what is the exact problem that happens. Okay, first step is understanding the problem. The problem should be understood completely by comparing with the earlier problems, by comparing with the solutions that are all taken in the earlier problems, by handling the earlier problems. Okay, that's the first step. Then the second one is determining the capabilities of the computational device. In which device you are going to solve your problem. That the device capability, that depends on the device capability itself also. Okay, so the computing device should be in an exact or in high architecture with a correct speed, and what are the memories that are all needed, that are all available. Memory availability of the computing devices should be important. So you should identify the capability of the computational device. Okay, then the third one is exact or the approximate solution. So what are all the possible inputs, what are all the legal inputs you all have to give to compute the answer that should be identified. So the solution is stated here in two forms. The first one is exact solution or an approximate solutions. Exact solution is to find for this problem this is the correct solution. For this problem you have to identify this is the correct solution. Or approximate solution means like this solution you are going to give, like this way you are going to solve your problem. That is known as the approximate solutions. Examples for an exact solutions cannot be obtained, like finding a square root of a number or solutions of a non-linear equations. Okay, then the next one is select the appropriate data structure. You all have to identify in which data type you are going to present your algorithm. Okay, in data type is a well defined data type. Is what's the definition of data type means? Data type is a well defined collection of data with a well defined set of operations in it. Okay, then a data structure, a different data type is different from data structure. Okay, data structure is a group of data elements, that the combination of data elements are designed in a way to store and organizing your data in a computer. How your data is stored in your computer, the group of data, how it's stored in your computer, that is known as a data structure. So different data structures are list, sets and dictionaries. Okay, then the fifth one is algorithmic design techniques. How you are going to create an algorithm. It's algorithm is creating an algorithm. It's by their own interest. So it's like an art. You have to handle the way how you're going to create an algorithm. So by mastering the strategies that are involved in designing, that's very easy to create your own and a new defined algorithm. That is algorithm design techniques. Okay, then the next one is methods of specifying an algorithm. In which method you're going to specify an algorithm. That means by using a natural language or any form of pseudocode or flowcharts. In which options, in which way you are going to specify your algorithm. Here natural language and a pseudocode and a flowchart. Pseudocode is defined as a mixture of natural language and your programming language. Natural language is a normal way of communicating English. Okay, programming language is a coding, a set of a software coding as a programming language. Okay, but the pseudocode is a combination of both natural language and programming language, like how constructs it created. Okay, then a flowchart is a pictorial or a diagrammatic representation of expressing an algorithm. So it's defined as a collection of connected geometric shapes. Okay, then proving an algorithm is correct. correctness. Next step is proving an algorithm's correctness. Okay, you have the necessity to show that your compute answer for all the possible inputs you gave, this is the compute answer that you have to prove in this step, that is known as algorithm validation. You have to validate your algorithm is correct. The input you are all given for the problem solving solution is correct. Okay, that is identified in this step. So the process of validation is involving in that how the algorithm will work correctly, exactly, that independently of the issues or the problems that arrived, that should be verified in these steps. Okay, then the next one is analyzing. After identifying the steps, you have to analyze how the algorithm is performed. That is the steps known as analyzing the performance of an algorithm. You have to analyze what you are done above in above steps, that should be analyzed. Okay, after the algorithm is executed, the computer CPU is to perform operation and its memory. So for what it operation, for what it perform its operations means to hold the program and data. Then how much computing time is taken for the execution, and how this algorithm, how much storage it requires, that are all analyzed in this steps. Okay, for this analyzing the performance means after the algorithm is executed, you have to analyze the computing time and the storage of an algorithm. Based on the analyzation, you have to make some quantitative judgments. Okay, based on that analyzing, you have to maintain the quantitative judgments for further reference. Okay, then after the algorithm is created, the final performance of the algorithm is denoted in this step. Okay, thank you.